In this exercise, we show that if a function f is continuous at c, then the absolute value of that function is also continuous at c. So we define the absolute value of a function like this. And then suppose that f is continuous at c. Thus, by definition, for any epsilon greater than 0, there's a delta greater than 0, such that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus f of c is less than epsilon. And what we need to show is that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus the absolute value of f of c is less than epsilon. And to do this, we're going to use a marvelous tool called the triangle inequality. But we're going to use the reverse version of it, which states that the absolute value of a minus the absolute value of b is less than or equal to the absolute value of a minus b. Applying this to our situation, we end up with the absolute value of f of x minus the absolute value of f of c is less than or equal to the absolute value of f of x minus f of c. Thus, if the absolute value of x minus c is less than delta, then, now we use the reverse triangle inequality to set up this inequality. And we already know that since f is continuous at c, that this absolute value is less than epsilon. We thus know that this absolute value is less than epsilon. Therefore, the absolute value of f is continuous at c.